Hello, everyone. This is Stephanie Landers, Manager of Industry Outreach and Stakeholder Relations at the Ontario Water Power Association. Welcome to our webinar today. I am going to start recording the webinar so that everyone is aware. The session is actually already being recorded, so just so everyone on the line is aware. We have two wonderful presenters today from Millstream Engineering, Inc. We have Greg Auger and Alina Stefanians, who are here to discuss eliminating oil and grease from turbines using Ontario-made Thornton bearings. I will be looking at questions on the right-hand side of the screen if anyone has questions during the presentation. And at the end of the presentation, we can also unmute lines to do questions as well. But in the meantime, I'm here if there are any technical difficulties, and I will let Greg and Alina take it away.
All right, awesome. Well, thanks, and good morning, everyone. Welcome to our morning webinar. I hope everybody's staying healthy and staying busy in our latest round of lockdowns. But we can think about nice, warm, sunny days on the river with the picture here on our title slide. If anybody recognizes it, that's just looking upriver, actually, at Wasdale Falls, which is just up the lake from where I live in Aurelia. And so anyway, hopefully those sunny, warm days on the water are coming soon. And but anyway, we'll give you a little bit of a diversion today, I guess, talking about Millstream Engineering, which is a relatively new company, as well as Thornton Bearings, which is the main brand and the product that we represent as the authorized distributor for Thornton in Ontario. So the kind of theme of today's session is, of course, to introduce our company and what we can do, but also to talk about some installations of Thornton bearings around Ontario in the last 1 or 2 years or so. And so we're trying to emphasize the fact that, you know, these are Ontario-made bearings. The factory for Thornton is just in Burlington, and that's where all the production and engineering happens for Thornton products. The polymers and the machining, everything is done in Burlington. And so we've supplied Thornton bearings into locations all across Ontario, from the north to the south and the east to the west. So our hope today was just to give you kind of some examples of the places that we've put Thornton in service in the last couple of years, and some of the reasons why the different projects were done and the different installations, the advantages and the benefits of each. So I'll give a little bit of an introduction, I guess, for myself. Anybody that doesn't happen to know me on the call, you might have recognized me in previous webinars with my Thornton hat on. So I was a Thornton engineer and sales and business development rep for the past 13 years at Thornton Bearings up until just the beginning of this year. And so in my time at Thornton, I worked in all different sort of projects, marine and hydropower, and really focused in on hydropower globally in the last few years. And then I think with the whole COVID situation, everything changed a bit, and my global role became a much more local desk-based role. And so we had the opportunity to sort of put together a plan and a pitch to set up as a distributor in Ontario for Thornton, and focusing more locally as an independent engineering company. And so we set up Millstream Engineering in early 2021. So I do have that background with Thornton, and then prior to that, a lot of background in product design, testing, and other manufacturing areas of mechanical engineering. And so then my partner in the business is Alina Stefanians, who also is a former Thornton employee, also a mechanical engineer and a PEng. And so Alina has worked in a couple different fields in addition to Thornton, but she's, you know, a really well-rounded mechanical engineer with a lot of background in mechanical design, prototyping, testing, project management. She has a lot of knowledge and expertise with plastics, with metals, with machining, casting, fabrication, all the different ways we can make things, and also looking at mechanical, hydraulic, and electrical systems, and trying to integrate those into different types of packages for water filtration or for other things that you might have in your plant. So what we're hoping today is that we can just really give you a good kind of overview of what Millstream Engineering can do, and also where we've put Thornton all around the province. So with that, I'm going to hand it to Alina to deliver the next few slides, and then I will come back in a little while. We will have time at the end for questions and discussion if there's any. And of course, you can type them in during the presentation as well into the question box. So with that, over to you, Alina.
Thank you, Greg. That was a lovely introduction. Good morning, everyone. I hope you're all doing well and staying healthy. So in the next couple of slides, I'll be giving you an overview of what we do, some of our current product brands, and how we can help our customers. Then we'll move on to some examples of some of our most recent work in the past year, and how Thornton materials can be used in hydromechanical equipment to decrease downtime, eliminate the need for grease lubrication, and improve the overall operation of the machinery. So having worked at Thornton Bearings, both Greg and I have many, many years of experience tackling bearing and sealing problems, which are associated with hydropower applications. And we both always enjoy a good mechanical challenge and love troubleshooting and figuring out how we can make things function better. Our team here at Millstream can offer specialized knowledge and expertise to different types of customers. For example, say for hydro utilities, we can help extend bearing and seal life. We can assist in sourcing mechanical components. We can offer our engineering services to complement their engineering capabilities. For service companies, we can supply mechanical products with a level of application knowledge and expertise that's typically not offered by general industrial suppliers. For equipment OEMs, we can provide quick response to RFQs, which we know is very important. And this we can do with clear proposals. We can help them pick the most optimum material for the application, provide the bearing sizing calculations, and help them implement the project. Currently, Millstream Engineering offers two brands of products, one of which is the globally recognized Canadian-made Thornton bearings. The other one is called Pack Flange, which is manufactured in New Zealand. Thornton Bearings is located here in Burlington, literally 5 minutes away from where I live, and it manufactures and supplies different grades of bearing materials, as well as custom manufactured water lubricated and self-lubricated bearings, shaft seals, and water filtration systems. So having worked at Thornton for so many years, I guess Greg and I have sort of become specialists in offering the right kind of Thornton product to our customers. Pack Flange is a somewhat of a newer brand of product that's offers self-contained conveyor bearing units, which is also safe for the food and beverage industries. Other than these two brands of products, we can also use our extensive network of contacts to help our customers source any other type of engineered mechanical product that's normally hard to source through the normal industrial channels or off of a catalog. So aside from the products we offer, we can also provide different types of engineering support and services to our customers. We are bearing and seal troubleshooting experts, and we love to solve challenging problems. For example, some of the things we can help our customers with are maybe to figure out why bearings are wearing out too fast or overheating, or we can help find out why seals are leaking too much. We're pretty good at reverse engineering old mechanical equipment and replacing old components with new ones. Or as Greg says, we love to make old things new and shiny again. We can also provide machining guidance and support to the shop that's machining the bearings, whether it's the customer's machine shop or a supplier's machine shop. And for installation, we can help in person by visiting the site or the machine shop that the bearing or the seals are being installed at. Or we can also provide guidance over the phone or provide written instructions if required. We also have the capability to do 3D modeling of components and full assemblies, as well as provide 2D drawings. For example, oftentimes we hear from our customers that, say during an overhaul, they found that some of the component drawings were missing. This is where we can come in and offer to measure up these components and make 3D models and 2D drawings for you. And the last but not least, we can also do different types of technical reports. We can do schematics, piping diagrams, and any kind of custom engineering report that is required by our customers. So we'll now switch over a bit and talk a little about some of our most recent work. And I'm going to do a couple of slides, and then Greg will take over and do the rest of the presentation. So one of these projects that was completed earlier this year is the OPG Crystal Falls. This power station is located just west of Sudbury on the Sturgeon River. In this case, unit number 4 was the one that was scheduled to undergo some repairs earlier this year. And this kind of presented the perfect opportunity to also look at replacing the wicket gate and linkage greased bronze bushings with some new material. So in this case, the material that we offered was Thorplast Blue self-lubricated bearing material, which we supplied in form of rough tubes to OPG Diamond Machine Shop. Our team at Millstream provided the sizing calculations to the machine shop and the engineering support and guidance that they needed to machine and fit these bearings in place. These bushings were installed successfully, and most importantly, they don't need to be greased anymore. The second project that was done earlier this year was for the Q1 power station, which is located on Niagara River. One of the units was scheduled for a minor overhaul earlier this year, and the overall goal was to eliminate grease and clean up the area. The old gate linkages in this particular unit were made out of just solid bronze, and actually you can see it in the bottom middle photo there, not the yellow part. The yellow part is actually the lever arm, and where Greg's pointing at, that's actually the solid bronze the solid bronze linkages. So these linkages were replaced with stainless steel material by OPG, which there's actually a picture at the bottom left. And Thornton supplied the Thorplast Blue material, again in form of rough tubes to OPG, and the bearing sizing, and OPG machined the bushings. Everything reassembled successfully as far as we know in March, and now there's no need to grease these linkages anymore. So with that said, I'm gonna pass it over to Greg to present the rest of the cases.
Perfect. Thanks, Alina. And so I guess the rest of the slides, it's going to feel a little bit like the OPG show for a couple more slides here, but then we'll get on to some other end users as well. So the next one here that I'll talk about a little bit is with OPG Ear Falls Station. And so Ear Falls is in northwestern Ontario, and it's also, as with many of our power stations in Ontario, it's pretty old. The units have been around since the 1930s, I guess. And so you can see in the top right corner, this is a cross-section of the original bearing design in there, which was a stave type bearing, very common in the older units. You've got staves originally, which would have been made of wood, and oftentimes they get replaced with different materials over the years, trying to track down the material and best sort of wear life you can get in that stave type design. The problem with the stave design in general is that there's a lot of space between the bearing surfaces, so you're not actually getting as good a support for the shaft as you could have if you have a full cylindrical bearing with less of that kind of groove area. And so one of the challenges at Ear Falls was that the wear life was relatively short, so the customer was having to make frequent bearing replacements or adjustments to try to keep the clearance as tight as they needed it. And one of the reasons that's happening, in addition to the material selection of the staves, is the fact that you have all those open spaces between them where your water is going through, and it's not actually helping to build up a water film which is supporting the shaft as it runs against the bearing. So the proposal that we made through Thornton was to replace the bearing with a cylindrical type of bearing. So actually modify the housing by machining out those stave pockets to get a full cylindrical bore, and then fit a split Thornton SXL bearing into the housing using the bronze taper key set. So you can kind of see that in this 3D model here. You can see the SXL bearing, you've got some grooves, and you've got the bronze key set which locks that bearing into the housing. So the key set actually is just installed with a simple tool using a small hydraulic cylinder and a cross piece, which actually drives the wedge key into place, which locks the bearing shell into the housing. It makes it easier for replacement in the future. But the most important design change here really is getting away from all those grooves you have in the stave bearing, all those water spaces that don't do anything to support the shaft. And now you've got much larger surface area on the bearing. And by having bigger surface area, you're reducing the bearing pressure, sort of the contact pressure between the shaft and the bearing, which helps to build up that hydraulic fluid film, the water film that we need, and actually separate the shaft and the bearing a little bit more, which helps to increase the wear life of the bearing and ultimately the time between replacements. The other interesting thing that we'll have at Ear Falls, the OPG staff were able to take some vibration measurements of the old bearing previously, before this new bearing was put in. So that's looking at the vibration of the shaft at the bearing turbine guide bearing location. And I believe the plan is to get back in there, and they will take some more measurements later in the summer or in the fall to try to have kind of a before and after comparison, looking at the vibration as well as the clearance profile in the bearing. So we should have some really good data to kind of show us how that bearing has improved the performance and hopefully improved the wear life as well. And I hope that in a year from now we can update everybody again on this project and with a good update on the wear life and better control of the vibration in that unit. So one more OPG one that we'll talk about, it's a little bit of an unconventional for Thornton, I guess, application, but it seems to have worked out really well. So this is at Lower Notch Generating Station. These are pretty big units at Lower Notch. It's on the Montreal River. It's a lot of water, a lot of power produced by those units. They're definitely newer than the Ear Falls ones, relatively young, put in 1971. And the application here actually was to use the self-lubricating Thorplast material as a support pad underneath the generator frame. So as you can imagine, you have a large generator with quite a large structure supporting it, which will expand and contract with temperature changes as the unit is running. And the thermal expansion and contraction from the temperature changes, if you don't allow that support to kind of expand and contract freely, then you can have some distortion of the actual generator frame. And so if you have metallic pads that aren't well lubricated and you have kind of a bronze on steel without any grease, or even steel on steel, as the frame is trying to expand, it's being resisted by the friction on those support pads, which can actually create some sort of distortion and stresses on the frame that's being supported. So in this case, we supplied through Thornton rough Thorplast sheets, which were machined then to the same geometry, the same size and shape of the pads, which were previously metallic pads. And so then they were installed in those locations underneath the generator to give that really low friction self-lubricating surface, which allows the whole thing to expand and contract more smoothly without putting any extra stress into the frame. So this was done, I think, about just over a year ago maybe now, and seems to be working quite well. Definitely not something that we've got in all the Thornton marketing literature, but it's been a great application for that self-lubricated material. So moving on from OPG, we have another project that we supplied. In this case, the bearing was supplied through Thornton to Lidestroy, working with Lidestroy in Quebec as well as in Slovenia. And then the end user in this case is Portage Power at the Hull 2 station, where Lidestroy is basically putting in, I believe, a new unit or substantially overhauled unit number 4. So the interesting thing in the bearing in this application is that it's a pretty large horizontal Kaplan machine. So you can see the shaft size in this bearing is quite a large diameter shaft. It's not a small unit. And because it's a horizontal application, there's a couple special considerations we have to think about in the bearing design. One is that we want the best possible hydrodynamic film formation, but we have a constant load from gravity acting on the shaft and the runner. So unlike a vertical machine where your bearing, your turbine guide bearing is effectively just trying to keep the shaft centered, in the horizontal machine, even from a standstill, you have to be supporting the weight of the runner and the shaft that goes through that bearing. So it's typical that the bearing itself will be larger, either in diameter or length or both. In this case, the length is probably 2 times the diameter, which is quite long compared to what you'd see in many vertical turbine bearings. But we also have this smooth bottom feature. So this is kind of the unique Thornton compact style. So compact material is very similar to Thornton SXL, but the sort of distinguishing feature is that we have grooving on the top half of the bearing only, and the bottom of the bearing is a completely smooth, uninterrupted arc, which helps to build up that hydrodynamic water film, just as you'd have in an oil and Babbitt bearing, where you've got the smooth section where you're building up that film hydrodynamically from the rotation of the shaft. It's the same operation sort of principle in the water lubricated bearing. So having that smooth portion of the bearing helps to get a thicker film and lift that shaft off the surface better at a lower speed as the unit starts to turn. The other interesting feature we have in this design, because it is quite a long bearing and the clearance is still quite small to the shaft, so you can imagine as the bearing gets longer, if you have any kind of angular misalignment of your shaft relative to the bearing support, a longer bearing is less able to kind of accommodate that angular misalignment. So in this case, at the center of this housing, there's actually a feature which is providing some self-aligning capability, sort of like a spherical bearing, but a really big version of it, so that the bearing housing itself can take the angle of the shaft that's coming through it, even if it's slightly misaligned in one direction or the other. So we worked closely together through Thornton with the engineers at Lidestroy on the design of this turbine guide bearing for this unit. So then to go from the big to the small, we also have this example in Gananoque, also with Portage Power now. We used to be Energy Ottawa. So this is a small vertical unit, 700 kilowatts, so it's pretty small, also pretty old, back to the 1930s. And the original bearing design in this case was using one of these quad block style bearings. So you've got the 4 blocks against the shaft, and each block is typically adjustable to try to get the clearance and the positioning correctly. And also so that you can adjust as the bearing material is wearing, you can adjust the blocks closer into the shaft. So historically, these would have either been metal backed with a chunk of wood on them, or they could have even just been a big solid block of wood in the 4 positions around the shaft. So at this location, there is no piped or pumped water supply to the bearing. It's really just depending on the water flooding into it from the turbine. And so it's somewhat susceptible to damage from water loss to the bearing. And so we have to be careful to try to keep the bearing lubricated at all times. But over the years, different materials have been tried in these blocks, and I think that generally the Thornton SXL has provided pretty good service life, time between replacements. And so it's actually been supplied in a few different ways, either as fully finished assemblies or refurbished assemblies, or the most recent case, we just supplied through Thornton some rough material which was machined to fit onto the backing plates locally by the end user in this case. So another project where I'm sure most people in Ontario have heard about this Bala Falls project that's operated by Swift River Energy, and the turbine itself was installed by Mavel, and you may not know, but it actually has Thornton in it. So we worked through Thornton with the engineering team in the Czech Republic at Mavel on the design and the sort of specification of the water lubricated bearing that's actually in that turbine. So it is Thornton SXL material. It's using the same bronze taper key set for fitting that I was describing for the Ear Falls refurbishment project. And so the bearing itself and the key set, rather than shipping it across the ocean to the Czech Republic to put it into the equipment just to send it back here, we just basically sent it when it was finished from the factory up the road to Bala, where it was then installed and assembled by the team that were doing the on-site work. So that's been in there now, and as I understand, it's running well and has been working fine without any problems since startup. And so we'll keep an eye on that one since it's 20 minutes up the road from my house. So it's another one that's quite easy for us to help out and support as needed in the future. And I'm just going to kind of finish with the last case here, which I think is a really interesting and unique one that I didn't even know was installed with Thornton until the last few months. But again, it's a project with Mavel. And in this case, Thornton supplied the SXL bearing material to the Czech Republic. It's quite a small bearing. So the rough material was shipped from Canada to Mavel's factory in the Czech Republic, where it was then machined and bonded into the bearing housing and assembled with the rest of the machine. The interesting part of this is that the turbine itself, if anybody hasn't heard of this project, it's actually on the outfall of the wastewater treatment plant in Peel region. So it's the Clarkson treatment plant, and it's a small Kaplan machine. So you can see in the picture here where the turbine is installed in this discharge pipe. And it's actually a 12-meter drop where the treated water from the sewage treatment plant is going back into Lake Ontario. And so by using a water lubricated bearing in that turbine, obviously the last thing you want to do is have a risk of oil getting into your freshly cleaned water that's going right back into Lake Ontario. So using a water lubricated bearing eliminates that risk of any kind of oil contamination completely. So you can kind of see in this schematic over here, it's a much bigger map. If you had the whole thing, it's the whole layout of the treatment plant and all the different stages from the point where it's sewage to the point where it's something clean enough to go back into Lake Ontario. But the turbine itself is actually installed for sort of this energy recovery just after the last clarifying stage. And then the water, after it goes through the turbine, goes back into the lake out through some diffusers on the bottom of Lake Ontario, which is really, I think, an interesting application. And I was really surprised and interested to learn that Thornton's material had ended up in this unit literally down the road from the factory. And Thornton didn't really know because we just had supplied it for Mavel in the Czech Republic without really knowing where the small bearing was ending up. So it's been kind of a neat discovery to find that out, I guess. And I think the advantage in this case is that they're able to recover energy from the process. And there's lots of other equipment which is certainly consuming electricity, but if you can pull some of that energy back out from that water that's dropping down to the lake, it's definitely advantageous in the overall project. So this was relatively small. The shaft size is 180 millimeter diameter shaft. Yeah, so that's that project. I guess the main thing that we just want to leave with you today is I think Alina and I have quite a lot of experience in our company working with all sorts of bearing and bushing applications. So if you're having any kind of trouble with your equipment, with your wicket gates, with your linkages, any of the regulating mechanism, turbine guide bearings, shaft seals as well, or as Alina said, any other kind of tricky mechanical challenges or problems, this is the stuff that we really love digging into. It's almost, I feel, kind of silly to say, but it's almost fun to go into really old drawing sets and try to piece together how everything's working and should be working. And so what we're hoping to be able to do is just bring that expertise to customers in the hydropower market in Ontario and kind of help complement and fill in the gaps wherever you may not have the expertise in the mechanical systems and bearings and seals. We're really happy to review anything that you can send along. So if you have a problem, you send some pictures or drawings, any kind of background. We're happy to take a quick look and provide some kind of feedback and our thoughts on what might be possible. If it looks like it's going to take more in-depth engineering work, we'll let you know. If it looks like it's going to take some special products or investigation, then we'll make those suggestions. But really, there's no downside for you to get another opinion on any kind of technical things like this. It's just more information. There's no cost for asking us a question and seeing what we can suggest. So I would encourage anybody that has something you're working on and kind of struggling with to give us a call and see what we can help with. So with that, I think we'll just kind of wrap up and open it for questions. If there is any questions, we're happy to take them now. You can certainly contact us by phone or by email, or I'd encourage you to check out our website as well. It's got lots of pictures and applications and things kind of showing the whole range of what Thornton Bearings can offer, as well as what Millstream Engineering can offer.